Imagine you had a machine that could make anything you wanted. Have you ever thought that before? Does it seem strange to you? No, this should come as no shock. This is now possible through the magic of 3D printers. Are you ready to unlock the power of 3D printing and unleash your creativity? Then you're in the right place. In this video, we'll take you step by step through the world of 3D printing. From understanding how it works to exploring the different types of printers and materials available. By the end of this video, you'll be a 3D printing pro and ready to start creating your own unique designs. Don't forget to like and share this video and subscribe to our channel for more 3D printing tips, tricks, and inspiration. Let's get started. A short history. As technology has advanced, so too has 3D printing. Scott Crump came up with FDM printing in the 1980s. With this method, an object is made by heating a filament of plastic or another material and pushing it through a nozzle. This method quickly became famous for its affordability and ease of use. In the 2000s, improvements in materials and software made it possible to print objects that were more precise and complicated. Also, the ability to print in more than one material and more than one color has made it possible to make more things with a 3D printer. Today, 3D printing is used in a wide range of industries, including healthcare, aerospace, automotive, and more. From creating prosthetic limbs and surgical tools to printing aerospace parts and even entire buildings. 3D printing has also made inroads in the consumer market, with more and more people using technology to create everything from jewelry and fashion accessories to household items and decorations. The future of 3D printing looks even more promising as research and development continue to push the boundaries of what's possible. Everything is possible, from printing with living cells to make human tissue to printing whole buildings. That's why it's an exciting time to be a part of the 3D printing community. And we hope this video has given you a glimpse into the history, development, and potential future of this amazing technology. What is 3D printing? 3D printing, also known as additive manufacturing, is a revolutionary technology that allows us to create three-dimensional objects by adding layers of material. This means that instead of traditional manufacturing methods where the material is removed or shaped to create an object, a 3D printer adds material layer by layer to create an object. Here we start with a blank slate and build our creation piece by piece, placing each component exactly where we planned it. Additive manufacturing techniques, such as 3D printing, build up an object layer by layer. But how? Well, one must first create a digital drawing of the desired item. After that, the computer prepares a unique file format to send to the 3D printer. After the 3D printer reads the file, it can start printing each layer of the object. It's interesting, right? Engineers are using 3D printers to make jet engine parts that are lighter and stronger. This helps planes use less fuel and work better. Medical professionals are employing 3D printers to create customized prosthetic limbs for their patients. Chefs who are pushing the limits of their craft have made dishes that were incredible and unimaginable before. And hospitals are using 3D printers to make new body parts for patients, such as new bones to repair extremely severe facial or hand fractures, and even objects from cartilage, the material from which your ear is constructed, to make new ears for patients who may have lost theirs in an accident. Let's see how these 3D printers actually function. However, before we can begin printing, we must first create a 3D model on a computer. You may get 3D models to download and print from a wide variety of websites. Or you can use 3D modeling tools to create your own models. In terms of software, your options are extensive, but basically, they're all employing the same technique. You start with a simple form and change it by changing its size and shape, adding other forms to it, or taking away parts of it. You can go to the next step once you have completed the model to your satisfaction. In order for the printer to grasp the shape and print it correctly, the 3D model is scanned by the software, and its intersections are sliced. Then it goes to press. However, you must have the filament as a prerequisite. The models are manufactured using filament. You can print on a wide variety of media, from plastics and metals to ceramics and even chocolate. There are two primary mechanisms in our printer. One is a print bed that can travel in any direction, and the other is a print plate that can move up and down. When the filament is fed into the print head, it is heated by a heating element and melts. With the melted filament, the printer traces the outline of the first slice and fills it in. The dish lowers in order to print the following slice. To finish your model, you must repeat this process until all of the slices have been printed. Materials used in 3D printing. 3D printing can use materials as different as plastics, metals, food, and even the living cells that make up your body. PLA is the standard material for 3D printing. Basically, it's safer to use. It's convenient for printing, and you can choose from a wider range of colors. There is also ABS plastic. It's a more durable plastic that's also more difficult to print on. There are a lot of other materials used in 3D printing, such as rigid nylon filament, lighter carbon fiber, and bendable TPU. Timber, metal, and a gloomy PVA compound are also used in 3D printing. A 3D printer can print all of these materials. PLA 2, another material, is the source of glowing wood filament. If your printer can print PLA, it can probably print the other materials mentioned above. 3D printers of various types. Three of the most well-known ways to make plastic parts with 3D printing are stereolithography, SLA, selective laser sintering, SLS, and fused deposition modeling, FDM. Stereolithography, SLA. Stereolithography is still the best way to make high-quality 3D prints. It was first made in the 1980s. SLA 3D printers use a process called photopolymerization, in which a laser is used to cure liquid resin into a rigid plastic. SLA resin 3D printers have become very popular because they can make prototypes and parts with precise details and a smooth finish in a wide range of cutting-edge materials. The optical, mechanical, and thermal properties of SLA resin formulas let them compete with standard, engineering, and industrial thermoplastics. High-detail prototypes like molds, patterns, and functional items that need precise dimensions and polished surfaces can greatly benefit from resin 3D printing. Outside of the traditional industrial and design sectors, SLA 3D printers have a wide range of applications. Selective laser sintering, SLS. SLS 3D printers use polymer powder into a solid form using a high-powered laser. During printing, the powder that hasn't been fused yet acts as a support structure for the part, so there's no need to separate supports. So SLS is great for printing complicated geometries. The strength of SLS printed items is similar to that of injection molded parts, and the parts have great mechanical qualities overall. Selective laser sintering is best done with nylon, a popular thermoplastic used in engineering that has strong mechanical properties. Nylon can handle a wide range of natural and man-made stresses, such as impact, chemicals, heat, UV light, moisture, and dirt. SLS is a popular way for engineers to make functional prototypes because it is fast, doesn't cost much, and uses materials that have been used before. Fusion deposition modeling, FDM. Most people who want to print at home choose fused deposition modeling, FDM, which is also called fused filament fabrication, FFF. Fused deposition modeling 3D printers, FDM, work by melting thermoplastic filaments like ABS, acrylonitrile butadiene styrene, or PLA, polylactic acid, and pushing them out through a heated nozzle. The part is built up layer by layer until it is finished. FDM 3D printers are great for making simple proof-of-concept models and quick, cheap prototypes of simple parts like those that are normally machined. But compared to SLA and SLS, FDM has the lowest resolution and accuracy, so it's not the best choice for printing complicated designs or things with lots of small parts. Mechanical and chemical polishing procedures can produce superior results. Industrial FDM 3D printers with soluble supports can help with these problems and provide access to more technical thermoplastics, but they are also quite expensive. 3D printing has revolutionized the way we create and manufacture products. From rapid prototyping to producing end-use parts, the benefits of 3D printing are clear. It allows for greater design freedom, faster turnaround times, and cost savings. As technology continues to evolve, we can expect to see even more exciting developments in the future. Stay tuned with us to learn more about the latest advancements in 3D printing and how they're shaping our world. Thank you for watching.